Wasabi, you guys. We have a cool looking integral from homomorph, and we have a cube root here, then x squared minus x cubed, and some 1 plus x here at the denominator from 0 to 1. So yeah, what on earth do we do here? Well, so this takes a lot of messing around, and I mean a lot of messing around with stuff. This integral is literally super tricky to work with, like extremely tricky if you don't know what you're doing. So I'll just go ahead and just straight up show you guys. You can figure out this on your own, but good luck. It's very sneaky. But other than that, I'll go ahead and get right into the solution. So cube root x cubed. The first thing I thought about was just caveman. Well, actually no, I lied. It was first trig sub, but then the x cubed. What am I gonna do with that, right? So instead, I realized, you know what? Screw it. Caveman. I'll do caveman. So just give it a. That was a very fat line. X, and then here we get 1 over x minus 1. And here I decided, ooh, you know what? I just want to get rid of this radical. I want to get rid of this, right? The best way to get rid of a radical like this, especially when you're able to isolate x like that, is to do a force u sub, right? So that's force u sub, the cube root of 1 over x minus 1. We get u cubed plus 1 equal 1 over x. Then, well, we can't really, oops, we can't really derive both sides like that because we don't have x squared. So, unfortunately, we need x u cubed plus 1 dx is equal to negative u cubed plus 1 square, 3u squared. 0. That gives us infinity. Oh, well, that negative is going to take care of the balance for us. So infinity here. Plug in 1, we get 0, 0 here. Okay, cool. We have x. We have x here, which is equal to u cubed plus 1. 1 plus x. Ooh. 1 plus x. Or let's see, that's going to give us like u cubed plus what, 2? Yeah. I just don't want to like rush and like mess up somewhere, if that makes sense. This is just u, right? We u subbed that whole thing. And then du is 3u squared u cubed plus 1 squared du. Okay, so this cancels out, this cancels out. We are left with like 3u du, and then I think this cancels out too. Wow. So we're left off with u cubed plus 2. Ah, amazing. Thank God we have 0 to infinity, because you know what this means, right? What you can do, let me actually make this a lot simpler. Let w equal u over cube root of 2. So what I'm doing is I'm factoring this 2 out. Okay, so this is now a 1 divided by 2. Let w equal u over cube root of 2. So that now this is w cubed plus 1, right? And then let's see, u is equal to 3 cube root of 2 w dw. Is that it? No, that's not the only thing. The derivative, we have du cube root of 2. So we also have another cube root of 2 as well. Okay, just be very careful with that. So we pretty much have 3 times cube root of 4 over 2. 0 to infinity. And this can become a beta function, right? If we let w cubed equal t, right? Get t plus 1. We have t 1/3 equal to w. dw is equal to 1/3 of t negative 2/3. So we have 1/3. 1/3 is going to cancel this out. And then t of negative, what, 2/3? Times, we have, don't forget that w, right? We have t 1/3 dt. And now we can make this into a beta function. So now what we have is t plus 1 dt, and this t in overall gives us negative 1/3. Okay, awesome. So what this means is we can now use beta function, right? We need this to be m minus 1, and this is pretty much 1, which equals to m plus n. So cube root of 4 over 2, beta function of, let's see, 2/3, and then of course 1 minus 2/3. And you already know what this is, right? We've seen it before. It is the Euler's reflection. So we get cube root of 4 over 2. So from Euler's reflection, we get pi cosecant of pi x. What is x? 2/3. Right? We can actually simplify this a lot further. You know, this is cube root of 2. This is actually pi over cube root of 2. Okay? And then here, cosecant of 2 pi over 3 is what? Root 3 over 2. So 2 of root 3. Yeah. So our answer, this is going to kind of cancel out somehow. So we get like cube root of 4. So we get pi cube root of 4 over root 3. This is our answer. That, I feel like I might trigger some people with that. Let me rewrite this here. For you formal mathematicians, we get cube root of 4 pi square root of 3. There you go. And that is our answer, right? So a very tricky manipulation with beta function. Well, not really exactly beta function. I think it's just this part here. This part here was a little scary. This is very scary to do, right? It's not really natural to think like this. You know, taking the x out of its cave and then a forced u-substitution, thinking that everything will turn out nicely, right? That's the hardest part to see because it's not very clear. All right, very scary on this part, but then it simplifies very nicely. All you have to do is just use beta function. Okay. All right, very cool integral. Thank you, Homomorph, for sharing this, and I'll see you guys in the next video.